Hello and welcome to the fourth chapter in this tutorial series on the gameplay ability system. In this topic, we'll be implementing disables as in Dota 2, like root, disarm, silence, and the intersection of all, the stun. So if I run into this black disk, you'll notice that my movement has been stopped and I have been granted a state.pawn.root tag. Technically, I'm under the root effect that has prevented my movement and the rotation. And although I'm spamming my movement keys and trying to look around, I can only ever move or rotate if the state.pawn.root tag has been removed. So just by using tags, you can implement disables. And this actor to my left has an airborne ball, and if I run into this actor, whoops, this ball drops onto me, and I've been granted the state.pawn.stun tag. As with root, I'm unable to move or rotate, and I'm also attempting to perform melee, but melee is not being invoked. I'm only able to do the melee upon the removal of the stun tag. So this is what we will implement in this topic. In the first step, we'll be implementing the root and the stun effects. In my base folders, matter and volume of effect folder, alongside the other volume of effect actors that I had created in chapter 2, I've also created a couple of volume of effect actors, that is the root area and the ball drop. This root area actor has a sphere overlap component as its root scene component and has an attached static mesh component, which I have named it as plane. This plane is nothing but a static mesh cylinder, and its size has been scaled to 2.4, 2.4 and 0.02. And that's how I got this disk shape. I have used a black material called the tutorial material, which was part of this Unreal Engine project. And for the sphere volume component, its sphere radius is set to 120. It has been made to generate overlap events, and the collision presets being overlap or dynamic. And I have implemented its events on component begin overlap and on component end overlap. In the on component begin overlap event of the sphere, I wish to apply the root effect on the overlapping actor. This operation is very similar to the melee hit, where I have a root actor array property that is an array of actors. And so I'm validating this overlapping actor if it is already contained in the root actor array. If it is not, I'm adding the overlapping actor to the root actor array and using that overlapping actor to apply the root effect. So I shall attempt to get and validate its ASC, and using an effect spec of the gameplay effect root. To this gameplay effect spec, I'm using a magnitude using the assign tag set by column magnitude method, and I'm applying this gameplay effect spec to that overlapping actor's ASC. So this is very similar to the melee hit operation, where I'm applying the melee effect only after adding that overlapping melee actor to a hit actor array, and so this validation allows me to only apply the effect on a single actor. So in my ability systems effects folder, I have created a new disables folder in which I have all of the gameplay effects for my disables. Let me show you the gameplay effect root. This is nothing but a duration effect where its magnitude will be set by a caller tag, state.pawn.root tag. And down in the granted tags property, I shall grant the state.pawn.root tag to this applied ASC. So that's all there is to it for a root effect. Just grant a tag for a particular duration which is set by a caller tag. And that caller tag was what was used in the root area actor, which has a float property root duration that is set for 7 seconds. And so this gameplay effect root will be applied for 7 seconds. Similarly, in the matter and the volume of effects folder, I have the ball drop actor, which is similar to the root area actor, but implements a sphere static mesh of the scale of 0.5 using the static mesh sphere and a rock marble material, part of the Unreal Engine starter content. So since I need to make this ball drop onto the player, I will set the simulation of physics of the static mesh and disable gravity. This will allow the ball to drop when this actor begins play, which will have to be enabled at a later time. This sphere static mesh has been made to simulate hit events, and the collision presets has been set to physics actor, and its component hit event has been implemented. This plane static mesh, like in the root area actor, is also a static mesh cylinder with the scale dimensions of 2.4, 2.4 and 0.02, and it uses the same rock marble material. This sphere volume root component has a sphere radius of 120 made to generate overlap events, and the collision preset set to overlap all dynamic, and I have implemented the events onComponentBeginOverlap and onComponentEndOverlap. This time in the ball drop actor, the onComponentBeginOverlap event of the sphere volume will just enable gravity of the ball static mesh by using its setEnableGravity method and setting the gravity enabled parameter to true. For the onComponentHit event of this ball static mesh, I'm doing the same root actor operation by just simply copy pasting that code, and I may not even have changed the root actor array name to maybe stun actor array. But yeah, well, just making an effect spec out of the gameplay effect stun class and using a float property stun duration of the value 7 and applying that gameplay effect spec to the ball hit actor. So in the same ability system effects and disables folder, I have the gameplay effect stun class, which, like the gameplay effect root, is a duration effect set by the caller tag state.pawn.stun and granting the tag state.pawn.stun to the ASC of this effect. I have placed my actors in the level. Let me run this player into that root area effect, and you'll notice that in the debug information, there was the state.pawn.root tag granted in the own tags, which disappears after about 7 seconds. In this step, we'll be implementing the Haste rune effect. In my base folder's matter and pickups folder, I have created the Haste rune effect beside the bottle and the tango pickup actors. This Haste rune actor is nothing but a sphere static mesh, and it uses a Haste rune material that I created in the same folder. You may create a new material by right-clicking on an empty space in the material section, choosing the material option. I shall name this new material test. To this material, I just added a constant 3 vector to the base color and a constant value to its roughness. You can change this constant 3 vectors color to whichever color you'd like, and you can change the constant value for the roughness. A high value makes it more rough and less reflective, whereas a low value makes it more smooth and can even go to the negatives and has a more glossier surface. So I shall close out of this class and delete this test material, since I've already created mine to be the color of blood red, as in Dota 2's Haste rune. So after setting the material, I set this actor to generate overlap events, and the collision presets to be overlap all dynamic. I have implemented the onComponentBeginOverlap event, and in this event, for any overlapping actor, I shall attempt to get and validate its ASC and apply a gameplay effect to that ASC, for which I shall use the gameplay effect rune Haste. And soon after the application of the gameplay effect, I shall destroy this Haste rune actor. In my base folder's ability system and effects folder, I have created a new buffs folder, within which I have the gameplay effect rune Haste. This effect is a duration effect of the duration magnitude of 10 seconds. It has only one modifier, which overrides the movement speed attribute to a value of 9999. So technically, any game designer should be able to set a high value to this gameplay effect, and your program should be able to handle such an unreasonable number. Because as a game designer, their intent would be to maximize the movement speed under such effects, and a program shouldn't really have unexpected results. In fact, I will deliberately set a value of 1,000,000, so like in Dota 2, you may want to maximize the movement speed and override to a very high number. So 1,000,000 is not a valid or a reasonable movement speed in most games, unless your character is Barry Allen. After adding the modifier, in the granted tags, I shall add 2 tags to this applied ASC actor, the buff and the movement. This buff tag was created in the external JSON source file, tag state, and so in the model folder, in the data table gameplay tag state pawn, you can just click on re-import to have those tags in your project. So it's like I'm saying this gameplay effect rune Haste is actually a buff but for movement, and that's all there is to it. A duration effect for 10 seconds, overriding the movement speed to 1,000,000 and granting the buff and movement gameplay tags. So to handle this case of 1,000,000 value, you can clamp the movement speed in the battle attribute set's pre-attribute change method, which you may have already done in the topic 1.2 on attribute sets. I shall now play my level and use the show debug ability system console command in one of the clients, And upon consuming the Haste rune, you can see that I have a movement speed of 2000 despite its value being overridden to 1,000,000. And it also indicates under which effect this has happened, the gameplay effect rune Haste. And after about 10 seconds, this effect expires and the movement speed is reset to 600. So now we have to somehow bind this attribute to the in-game walk speed. And this can be done using the character movement component. So in my project C++ classes directory, in the project folder's public folder, I have a new utils folder, within which I have the base character movement component class. This is the child of the character movement component class, the one you see in your characters. So technically, we are going to be implementing our movement features in our own character movement component and granting that to our base character class. So in your Unreal Engine editor, click on the Tools menu and the new C++ class option. In the All Classes section, search for character movement component. You can see that I've already implemented my base character movement component, that is the child of the character movement component. So select the character movement component and click Next. Name your character movement component class, and in the path, type utils. Click on public for the class type so that your header file is in the public directory and your C++ file is in the private directory, and just click on create class. But I shall cancel this step since I already have my character movement component. And in your IDE, this is what your character movement component will look like. So right click on the parent character movement component class and click on go to definition. This will take you to the character movement component header file and search for get max speed. So this will take you to the line of get max speed declaration, and we're going to override this method. And this method is actually part of the U movement component interface. So copy paste that method declaration in your newly created movement component class. In Visual Studio Code, I will just right click on the method name and click on create declaration or definition. And VS Code shall create this method definition in its C++ class. And I almost forgot to mention, this getMaxSpeed's return value is a constant float value. So just to test this movement component, and if this getMaxSpeed method is being invoked, I shall just simply log a message using the uelog method. As for the return value, I shall simply call the superclass's method getMaxSpeed. And now it's time to construct this into our base character. So in my base character's header file, I have implemented another constructor. This is actually method overloading. So technically, this constructor helps in setting default values for this character's properties. And this is what this constructor's definition will look like. This is the same implementation done in the GASDocumentation project, where they've implemented their own character movement component and overrode the getMaxSpeed. And that movement component was constructed in the base character class. So just implement in the same way by copy pasting that code. You just have to change this character movement component's class name. And also don't forget to include your character movement component header file. And this can be done in the base character C++ class. So this is in a way constructing this new base character movement component and initializing this over the existing character movement component. So when I play my level and the player loads onto my level, if I check my output log, you can see that the getMaxSpeed log message is being printed every periodic tick. So this means our newly created character movement component has been successfully initialized, constructed in our character, and the getMaxSpeed method is being executed. And so now it's time to implement this getMaxSpeed method. So in the base character movement component C++ class, I shall include the relevant header files, that is the game framework character, the gameplay tag container, the ability system blueprint library, and the battle attribute set. The first step is to get the ASC, which will be done using the ability system blueprint library's getAbilitySystemComponent method, and for its input parameter, I shall call the method getOwner. So technically, this getOwner method returns an actor object pointer that is the owner of this component, and that actor will be used for this getAbilitySystemComponent's input owner parameter. So now we shall validate for the stun or root disables. During the stun or root states, I want to prevent any kind of movement in my character. So if my character is stunned or rooted, this method shall return 0. So in a return statement, I shall use a ternary operator because they are the shorthand notation of a simple if-else return. And this will be my logical expression to validate for root or stun. So I shall call the ASC's method hasMatchingGameplayTag and pass in the gameplay tag state.pawn.root. And I shall use the logical OR operator and use the same ASC's method hasMatchingGameplayTag and pass the state.pawn.stun gameplay tag. So what does this logical operation mean? Well, this hasMatchingGameplayTag method of the ASC returns a boolean value and takes in the parameter a gameplay tag, just like in the blueprints. And the gameplay tag is passed using the fGameplayTag class method requestGameplayTag, and that in turn requires a parameter, the name of the gameplay tag, passed as a string. If either one of these return values are true, then this logical expression will be a true. This logical expression can only be false if both the operands are false. So the true value of ternary operators are written first, and after the semicolon comes the false value. So I shall just return the movement speed as 0 if this owner actor's ASC has the tags root or stun. So now build and compile your code. And in my level, in one of the client players, I shall show the debug information and run into this root area actor. And wow, you can see that having had the state.pawn.root tag prevented any kind of movement even if I'm spamming the movement buttons, until the removal of that state.pawn.root tag. And now similarly in the stun actor, if I get hit by the ball, I shall be applied the state.pawn.stun, and again only after the removal of the state.pawn.stun tag could I move my character. So yeah, technically the getMaxSpeed method, which is being invoked every periodic tick, is actually returning 0 when the ASC of this actor has these tags. And now it's time to change the game speed based on the movement speed attribute value. So in the same getMaxSpeed method, validate that ASC, and now I shall attempt to get the battle attribute set and calling the ASC's getAttributeSet method. This method returns the attribute set object pointer, and it takes in the only parameter, the attribute set class. I shall pass the static class method of the battle attribute set class, and that returns the class pointer of this battle attribute set. So you can notice a red squiggle under the ASC, and that indicates an error where the return value of the constant attribute set object pointer cannot be used to initialize constant battle attribute set object pointer. This can be easily resolved by simply casting this object pointer to the battle attribute set class. So if we fail to get a battle attribute set object, we can just return the superclass's method getMaxSpeed. And now the only thing that's left to do is to return that movement speed attribute value to be our in-game walk speed. So in the false condition of this ternary operator, that is where I shall return the movement speed value by using the battle attribute set's getMovementSpeed attribute accessor method. And that's all there is to it really. You can just build and compile your code. And if I consume this Haste rune actor, not only have I got that movement speed increase, I'm indeed moving at a high velocity. And so our movement speed attribute value worked. So now whatever value would be your movement speed, that will be the corresponding in-game walk speed. As a small assignment, I want you to create a new sprint effect and use that in the sprint ability. Make sure to use the appropriate ongoing tag. And also, this movement speed attribute value implementation is not entirely efficient. There is a better way to actually get that value in such periodic ticks. That will be done using event listeners in the future topic 4.3 for the UI. In this step, we'll be implementing the silence and the disarm effects. In my base folder's ability system and abilities folder, I have created a new anti-mage folder. And in this anti-mage folder, I've created the blink ability, as with anti-mage in Dota 2. This blink ability for now just prints a log message on the screen upon activation, nothing much to it. During its activation, it implements so many tags in its cancelled abilities with tag, and in the block abilities with tag. In a real-world practice, you don't really have to do it this way. This was done deliberately to make a point. You may grant an activation tag in the activation own tags to this owner ASC, and use that activation tag in the block tags in all the other abilities. In the blink abilities activation block tags, I have added the state.pawn.silence tag. So now it's time to grant this ability to a character, for which I have created new ability slot tags using an external JSON source file. This JSON file contains the tags of ability slots 1, 2, 3, and ultimate. And in the model folder, I have created a data table called gameplay tags ability that imports these tags by using that JSON source file. And in my project settings, in the gameplay tags section, I have added this data table to the gameplay tag table list, and I can see the new ability slot tags. In the initial ability container property, I have mapped the blink ability to ability slot 1. And now in my player controller blueprint class, I have a new blueprint comment section for abilities. The QDebug key shall activate my blink ability, so I shall get the control pawn and query for the ability at the ability slot 1 and call its ASC's try activate ability by class method. So now in my level, I'm able to activate the blink in my client 1 and able to activate blink in the client 2. Now in my melee ability, I shall add 2 tags to the activation block tags, that is the state.pawn.disarm and state.pawn.stun. And similarly in the block ability, I shall add the state.pawn.stun tag to its activation block tags. So now in my effects and disables folder, I have the other 2 disable gameplay effects, disarm and silence. Silence is a duration gameplay effect whose duration magnitude is set by a caller tag state.pawn.silence, and it grants the gameplay tag state.pawn.silence on the affected ASC. For simplicity, I shall change the duration magnitude to about 3 seconds. Similarly, in the gameplay effect disarm, it is a duration effect of a scalable float magnitude of maybe 5 seconds. And in the granted tags, I will add the state.pawn.disarm tag. So now in my root area actor, I will change the applying gameplay effect class from gameplay effect root to gameplay effect silence. And in the ball drop actor, I'll change the gameplay effect from gameplay effect stun to gameplay effect disarm. So let me compile this class and play the level. And in one of the client players, I'm able to activate the melee ability and the blink ability multiple times. And if I run into the root actor, you can see that I'm able to do the melee ability, but I'm also spamming the button Q and my blink ability is not being activated. And you can see its activation only upon the removal of that silence gameplay tag. Similarly, for the ball drop actor, I'm not able to do the melee ability even if I'm spamming my left mouse button. However, I'm able to do the blink ability just fine, because we hadn't blocked the blink ability's activation using the stun tag. So in this manner, by simply using tags, you can block the activation of some abilities, and these tags can be granted using duration gameplay effects. The sixth step is an assignment. So in my level, you can notice how my character is rotating so freely, like as if its rotation is bound to the mouse. While this can seem like a very fluid rotation, it may not add to that immersion. So I want to rotate this character using a particular rotation rate, as in Dota 2, where every hero has a turn rate and they turn around before moving to a new location. And also, if I step onto that root area actor, you'll notice that even under the root state, I'm able to look around, and I don't want to have this feature for the root disable. Although the character can look around, I want to keep their location and rotation in place. So this is what you'll be implementing for this assignment. And it is a very simple 3-step process. In your Blueprint Hero class, in its class defaults, search for rotation. In the rotation, disable the use controller rotation yaw property. Now let me compile this class and play the level. You will notice that my character is not rotating, even if I move the camera using my mouse. That is because we prevented the controller's yaw rotation. So make sure all these properties are set to false, and you can use any value for your rotation rate, preferably a value below 500. So the second step involves implementing a function in this base character movement component class. We will be overriding a parent class method. So right click on the character movement component and click on go to definition, and you will have to override this method, update character state before movement. And the third step involves manipulating this use controller desired rotation property. Although this is declared as an 8-bit unsigned integer, you can simply use a boolean value to this property. It is like setting this use controller desired rotation property in the blueprints to true or false. So this should be done inside that method. This use controller desired rotation is what rotates your character in the direction of your controller. So your controller always has a movement and a look rotation. If that is set to true, you'll see that the character is rotating, but with a slight delay. So technically it has a particular turn rate, like a speed at which it turns, and this rotation should be disabled when this character is rooted or stunned. So pause this video and implement this feature. So I hope you have returned to this video after completion of that feature, or at least attempting that assignment. So first, let me declare this method, and in the method definition, first I'll call the superclasses method, and within an if block of code, I shall operate on this owner's ASC. So the point here is that if I'm not stunned or rooted, only then can I rotate by the controller. So it will involve setting a boolean value to this useControllerDesiredRotation property. So to this useControllerDesiredRotation property, I shall set a boolean value accordingly. Let's attempt this ternary operator again. I shall copy paste the logical expression. So the true value happens if either one of the conditions is true. So if I'm rooted or stunned, I can't rotate, right? So as you can notice, this is just an inversion of this logical expression. So I shall remove those true and false values and just invert this logical operation. And as you know, this exclamation negates any logical expression. So technically, I can only rotate if I'm not rooted or stunned. So now let me build and compile my code. So now when I play my level, you'll notice that I have a turn rate. And wow, when I step onto that root area actor, my character doesn't rotate and can only rotate after the root expires, just like my movement. So in this manner, in this topic, we have taken care of the movement and the rotation during these root or stun gameplay effects. So why did we modify this useControllerDesiredRotation property in this update character state before movement method? That's because this getMaxSpeed method is actually So this brings me to the end of this interesting topic on Dota 2's disables. I'm sure you'd be implementing such kind of a disable in any of your project that implements an ability system, because some effects might require you to stop the movement or change the movement speed. And although the root effect is being applied, you can't really see any visual effects, no animations or some kind of a particle system. So this will be done in the next topic, that is the gameplay cues. So for both the stun and root actors, you can apply such visual effects and also play some animation. We implemented 2 volume of effects, root area and ball drop. Both are very simple actors really, where the root scene component is a sphere volume, within which there is a sphere static mesh and a cylinder static mesh. This ball component is what will apply an effect, so it has been set to simulate physics, but the gravity disabled. It will generate hit events, collision presets set to physics actor, and we implement the on component hit event. The sphere volume of the radius 120 will generate overlapping events and implements the begin and end overlap events. So the begin overlap of the sphere just enables the gravity of the ball, whereas the hit event of the ball applies an effect onto the hit actor. This hit actor has been validated for in the same way that we did in topic 2.1 on Melee, where we used an array of actors to make sure we're not operating on the same actor more than once. So we shall only do this operation and then get its ASC and apply the stun effect spec. The same thing has been done in the root area actor, and the gameplay effects root and stun are set to be duration effects for a duration magnitude and granting the relevant root or stun tag. We created a new actor called Haste rune, as in Dota 2, which was nothing but a static mesh sphere with a simple red material. Upon overlapping any actor, we applied the gameplay effect rune Haste, which simply set the movement speed value to about 1,000,000 for the duration of 10 seconds. 1,000,000 was an unreasonable speed, so I have clamped that value between 0 and the max movement speed of 2000 in our battle attribute set's pre-attribute change method. The third step was the most crucial step of this topic, where we implemented our own character movement component. We constructed this character movement component using the constructor's object initializer, and this character movement component just implemented two methods, getMaxSpeed and update character state before movement. The getMaxSpeed method got the battle attribute set, and we got the movement speed attribute value to return the in-game character walk speed. We also returned a value of 0 if the character was rooted or stunned. The fifth step was the blink ability, where in the anti-mage folder, we created the gameplay ability blink. We blocked the activation of this blink ability using our silence tag, and added the blink ability to our ability slot 1. We also blocked the activation of our melee ability with the disarm and the stun effects, both of which are a duration effect with a duration magnitude and granting the tag of the relevant disable. We prevented the rotation of the character based on the root or stun condition. It was nothing but the inverse of the logical expression if the actor was rooted or stunned. So if rooted or stunned, no rotation. That is nothing but the modification of this property in the character movement's rotation. And now you can set a desired turn rate value to have different turn rates as in Dota. And that's all there is to it. And this brings me to the end of this topic. I hope you had fun learning this. So thank you for sticking so far. If you think there are ways that I can improve, leave your remarks down in the comments below. So thank you for watching and see you in the next one.